Hello Velociraptors and welcome to Barton Springs. If you haven't had a chance to check out this iconic geologic feature of Austin, I'd highly recommend it. Barton Springs is part of the Edwards Aquifer, a porous underground system of limestone saturated in water. But this aquifer didn't create itself overnight. It was created through several sequential steps in Texas's geologic history.
For the story of the aquifer, you're going to be using the following legend to help illustrate the steps and processes that went through to help create the Edwards Aquifer. Now, hopefully you've already accessed the document and you've got this downloaded on your device, you've printed it out, or some way you're following along with the steps. Now, a few notes as you go through this. I would definitely go ahead and pause the video and get the following colored items. If you need to. You can create your own key, but if you do, make sure that you have mine beside yours so that you don't get lost in creating the key. Second is, as I go through this, I'm going to explain some of the processes or actions that are going to be taking place during each of these scenes. Make sure or feel free to flip over and write on the back or take some notes along the sides to help you remember exactly what's happening in each of the images. Because later, if you don't have those little annotations, you're going to have trouble remembering what little techniques or little pieces that we were discussing today. So let's get started with the story of the aquifer. Our first scene here looks just like a bunch of lines. And what I want to do first is color it in.
Now I want you to take your time as you color it in. Take a deep breath, enjoy it. We're going to take our first here of this beautiful atomic tangerine and we're going to shade it in. I like to outline my edges before I get started with work. Next, we're going to do our second sedimentary layer here in crimson red. Now, I love a good crimson red. Oh, do you see that? It just looks great in that layer. I love to, again, outline the edges and then fill that in softly. Oh, isn't that just beautiful? Now we're going to go ahead and do this sandstone, and the easiest way to do that is kind of a polka dotted navy. You can kind of dot that out throughout. And lastly, to finish off our perfect little image here, let's go ahead and grab that cobalt blue. Now I want you to finely brush that cobalt blue all over the water to get that nice, deep, rich color.
Great, now we've got that done. Now you'll see here I also have some annotations that I'd like you to add to your image to help you remember what we're looking at in box 1. In box 1 we have Central Texas, and more specifically we have Central Texas under a shallow sea. So if you remember from our historical perspective of Central Texas, we know that during the Cretaceous period there was a lot of glacial melting up in the northern North America, and that water was then funneled down over Texas due to the mountain ranges on the east and west coast of the United States, and that created this shallow sea environment. And now we've already talked about in terms of what happens to the landscape when it's covered by a shallow sea. Well, you know that there are two types of geologic processes, deposition and erosion. In this case, the top geologic process is deposition, so make sure that you're kind of indicating that there as well. Because I have all of these sedimentary layers. So you see white, which is Precambrian, and then I have orange, red, and this dotted sediments, all sediments that are being deposited by this blue area, which is indicating of our ocean or shallow sea. So say it's a big sea, so don't think it's just a little pond necessarily. That's covering Central Texas and creating this deposition. Now, if we keep going through to box 2, we can see again we have lines. Let's take again a second to color that in, but this and you can see now we have a recession of the water. So, and later we'll get more into this terminology as we progress through the course. We have a regression, meaning that the water recedes. And when water recedes, that means that this left part of the landscape, these orange, so here if I can indicate that here for you on the screen, this area right here that's no longer covered by water, the main or dominant geologic process now changes. So over here, the dominant process is deposition. Over here, the dominant process is erosion. And that's going to lead to later when all of these processes are leading to this constant formation of differential loading. And right here, it's where it's starting because I have this area here where landmass is growing. You can see it's a little bit thicker, and here this landmass is decreasing. That's causing tension here in between those two parts, and that's going to continue to play a part because it's going to slowly shape and form the landscape that we have here. But let's go ahead and look at box 3. And again, now we'll take a second to color it in. We'll do it real fast, just like we did a minute ago. And you can see we have a new formation. So here I have this area where erosion was dominant. So it's actually eroded the entire layer here of white dotted area away. And my layer over here, covered by water, I have deposition occurring. So I still have a lot of sediment here that's appearing. It's also occurring because, remember, as this is eroding away, it's also washing sediment down here as well. So not only, that's how I have this occurring between places. Now, the new thing that's happening that we didn't necessarily see before, so if I flip back here to 2, you see that the red layer is purely solid red. But if we move to layer 3, you're going to notice that there's these little blue dots. And those blue dots are representing water. Because as this erosion occurs, now it's exposed this layer of red or limestone. And as that limestone erodes, it erodes irregularly. And it creates what we call this like Swiss cheesy limestone, as you can see here. And that Swiss cheesy limestone easily allows for the water to get trapped. So water seeping down into that limestone because now it's porous due to the erosion occurring. And that's going to play a big part in the creation of our aquifer. So, okay, now we've got this Edwards Formation. It's exposed, erosion's occurred, it's come Swiss cheesy, and it's accepting that water in. Let's go ahead and go to our next box. Now again, before I go there, let's watch. So look where my water level is currently. Now, when I go to my next level, I go ahead and color it in. My water level has transgressed. It's gotten much larger. It's now covered the whole landscape. And now I have, again, deposition is occurring across the board. But remember, on this side of the region, we've already had deposition occurring. So this side has a much larger sediment load compared to up here where deposition is now just occurring. But there's another key feature here is you're going to notice that in the red layer, we have these trapped water layers or pockets. Because all that water, so that water from the Cretaceous period, has seeped down through that porous limestone, and now since the water transgressed over it, it's deposited on top, and it's actually captured that water because it's sealed in between this layer of sediment and this layer of sediment. And that's right here, we're in the Cretaceous period. Now, we have a drastic change in water. So we've had this regression. Now we've transgressed. We'll talk about those terms later as we keep going. Transgression just meaning the water raised. Now the water takes a drastic step. So I want you to kind of pinpoint where we're at so you can think about it on the time scale. We're right here in the Cretaceous period, Mesozoic era, and we're covered by that shallow sea, roughly about 100 million years ago, somewhere around there. When we're transitioning through here to the Tertiary period, a lot's happening. The water regresses again. And we saw this image again in the historic view or from the historical perspective of Central Texas. You can see that in the early Tertiary, as we started the Tertiary, the coastline is way up here. And we're talking about the Gulf coastline. We're not talking about like a lake or waterline. We're talking about the waterline that's currently here. Is all the way up here in Texas. And then as we move through the Tertiary period, you see late Tertiary period, that begins to recede further and further down. And as it does that, that is causing more and more of that sediment to be deposited here and not as much up here. And we're going to see that again here in this image in our next box. So in 5, now I want you to also remember that this process that occurs in box 5 is not like an instant. It's not like an earthquake that happened one day. This is constant, slow process over time as that water continues, or that coastline continues to recede. And we'll quickly color it in here for you. And we see that now we have a new layer as well, and we have a lot of shifting that's occurred. So since I had all those, first my water has receded. It's way down here now. Second, I no longer have, I forgot what I was going to say. Water receded. Oh, I now have all this presence of sediment down here and less opportunity for sediment up here. And what that's causing is up here, the weight or mass is much lower compared to here, and it's causing cracks in the middle because all of that tension is causing the earth to want to bend a little bit because it's got too much weight over here compared to over here. And in order to compensate for that tension, you see that it begins to fracture or create these faults. This idea of what we're talking about is called differential loading, meaning that it's differentiated in terms of where the sediment is. Some of it, a larger portion of it is over here, while a smaller portion is over here. And that differentiation in sediment is what's causing this force or these faults that we see in the land. Now, also being mindful of current time. So remember, Cretaceous, 100 million years ago, that's when we were covered by the shallow sea, deposition was occurring. During the Tertiary time, roughly 15 million years, that's when this is occurring. I have this continual pull away of the ocean or the coastline back to where it currently is today, and that constant move away is causing more and more differential loading, and it's causing the slow motion of this land to pass back and forth. It doesn't happen in an instant, it's happened over time. Now, of course, this isn't where we are at present day. If we go to 6, we're much closer to present day, where's that? And we can see here that erosion has begun or has occurred quite dramatically, much more than we saw in our last picture in number 5. And we can see that now, since there's no water present here, that coastline is continuing to recede to where we are present day, that all of this erosion is exposing some of those under layers. So in number 5, we only had this gray layer present at the surface, that tertiary deposits. Now you can access every layer that was once covered due to that deposition occurring. And now that erosion has led to the key features that we see and allows us to access the actual aquifer. And if you think about where we are in Central Texas, you can kind of pinpoint where this is at. If you think about this upper region, this is more of our hill country. It's our drainage area. So when all that rain is running water down into this area, and in this area, we actually have direct access to that water. Now, a few things to keep in mind is that's Cretaceous water, and that water has to be recharged or replenished. So once it hits the drainage area, that water runs down then through the aquifer and recharges it. And that's why when you're driving through town, you're going to see those signs that say you're entering a recharge zone, because Austin is right on top of that. So if you're driving near to Barton Springs and all that, you're going to see those signs that let you know that now you've entered a recharge zone. That's where that water drainage is running in. So we refer to this as the recharge zone. And then lastly, over here, if we think about this as San Antonio down here, San Antonio still has access to the aquifer, but they don't have direct access. They actually have to drill down in what we call artesian wells in order to access that water, but they still have access to it. And that's what we refer to that zone as an artesian zone. So think about it as an artesian zone. They have to drill down to access the aquifer. The recharge zone has direct access, Austin. Hill country is that drainage area that funnels all that water to the Edwards Aquifer. Here in Austin, we have the ability to access the Edwards Aquifer directly at Barton Springs. We get to enjoy the cool water bubbling up from beneath the surface. This iconic geologic feature was part of a special order of geologic events, and I hope you take a chance to appreciate its grandeur.